Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will discuss about image pyramids in OpenCV. So till now, normally when we have used images, we have used the images of constant size. But sometimes we need to work with the images of different resolution. So for example, if I have an image and I want to search the face inside an image, this face can be of different sizes. So using image pyramids, we just create the images of different resolutions, and then we search for the object, for example face, in all of these images. So pyramid or pyramid representation is a type of multi-scale signal representation in which a signal or an image is subject to repeated smoothing and subsampling. So a normal pyramid, when you create a pyramid of images, it will look like this. So let's say this is the original image at the bottom. Then when you downscale an image using a pyramid function, it's going to give you this image which have the half resolution than the original image. And then when you further go up, it's going to give you the 1/4 of the original image, and then so on. So 1/8 or 1/16 of an image. Now there are two types of image pyramids which are available in OpenCV. First is called Gaussian pyramid and second is called Laplacian pyramid. So first we will discuss about the Gaussian pyramid. So Gaussian pyramid is nothing but repeat filtering and subsampling of an image. Now there are two functions available for the Gaussian pyramid, which is called pyr down and pyr up. So let's see them one by one. So I have this sample code which is just reading an image and then showing it using the IAmShow method. Now in order to use this pyr down function, you can just define a variable, let's say LR for lower resolution, and then you can use cv2 dot pyr down. So there are two functions you can see, pyr down and pyr up. So first of all we will see pyr down, and then we are going to pass our image as an argument here. So I'm going to just pass our image as an argument, and we are already showing the original image, and let's show the image after we have reduced the resolution of this image using the pyr down method. So pyr down is going to reduce the resolution of an image. So I'm going to just use LR here, and let's say this is the pyr down 1 image. Okay, so let's run this code and let's see what happens. So you can see this is the original image, and this is about, you can see 1/4 of this original image, right? So this pyr down method is going to reduce the resolution of an image. When you apply the same method on the second image, so let's say this is LR1, and then we create a second variable LR2, and when we pass LR1 as an argument for this method to create the LR2 image, then let's see what happens. So this will be LR1, and let's just say this is going to give us LR2. The resolution of image will reduce further. So let's see what happens. So this was the original image, this was the image which we got from the first pyr down method, and then we get this image which is further reduced in resolution. So this is the image after applying the pyr down method second time on the LR1 image. Okay, so you can see the resolution of image is reducing and it's creating a kind of pyramid, and that's why it's called the image pyramid. Now there is a method called pir up also available in OpenCV. So let's see what this pir up method do. So as you can expect, it's going to increase the resolution of the image. So here I'm going to just say HR for higher resolution, and then I'm going to just say CV2 dot pir up. Okay, and it's going to increase the resolution of an image. Now let's say we want to increase the resolution of this image, which is the smallest image which we got using the pare down method, right? So we are going to apply the pare up on the last image which we got using the pare down method, and let's see what happens. So when I'm going to use this HR2 here, and this we got from pair up method, and let's say this is the pair up one, and I'm going to just run this code, and you are going to see that we have converted this image, which was the smallest image, to a higher resolution, which resulted in this image. But when you see this image carefully, so let me just move this to this side, and this was the original image. So let me just minimize this. So this image we have converted to this image using the pair up method. So ideally this image should look like this, but you have to remember that this pair up image is not going to be equal to this image, because once you decrease the resolution using the pare down method, you lose the information about that image. So when you use pare up to just increase the resolution of this image, then you can see the result looks little bit blurred, because some of the information is loosed using the pare down method. So you have to keep this in mind, that when you want to increase the resolution after you have reduced the resolution, you are not going to get the same result as you might expect, that this image should look like this, but they are not equal images. So this image is just a higher resolution of this image, and it has nothing to do with this image. So these are the two methods which are available in Gaussian pyramid. Now if you want to create a pyramid of multiple resolution, instead of just using this pair up or pair down method repeatedly, what you can do here is, I'm going to just remove this and remove this code also. So what I'm going to do is, I'm going to copy the image into a new variable. So I'm going to just say layer is equal to img dot copy. There is a method available for copying the image, which is copy, and then I'm going to create the Gaussian pyramid array. Okay, so I'm going to just create a variable called gp for Gaussian pyramid is equal to, then in square bracket I'm going to just pass this image here as the first element of this list. Then what I can do is, I can use a for loop instead of just rewriting this pare down method again and again. And you might already know how to use for loop in Python. So for I in range, and here we can provide any range. So let's say we want to create 5 image pyramid. Okay, so 5 times we want to reduce the resolution, so we are going to give 6 here, because range goes the number minus 1. So whatever you give here, minus 1, right? So now what we are going to do is, we are going to just use our layer parameter once again, and then we are going to just call cv2.pairDown method. So pairDown, and then we want to just say layer, okay, and then we want to append to the Gaussian pyramid list. Okay, so we are going to just say gp dot append, and we are going to append the result of this pairDown to our list which we have created here. Okay, so this is going to just append this image to our list of images, and then let's just show this image using cv2 dot IamShow method. So cv2 dot IamShow, and here we can just say str for converting the integer to the string, because the first parameter you give to IamShow is a string parameter. That's why I'm converting the integer to the string, and the second parameter is the image. So let's pass this layer here. Okay, so you have the original image which will be shown using this line of code, and then you will see multiple number of images of different resolution using this code. So let's run this code and let's see what happens. So I'm going to run this code, and you can see there are different images resulted using that code which we have written. So this was the first image, which is 0, and then this is the second image, and then this is the third, fourth, fifth, and sixth. So sixth, you can see, have a very small resolution. So this is how you can use pairDown method multiple times using a for loop. Now, what are Laplacian pyramids? So Laplacian pyramids are formed from the Gaussian pyramids. There is no exclusive function for creating the Laplacian pyramid. So as you have seen that in Gaussian pyramids there are two methods available, pair up and pair down, but there is no exclusive function for creating the Laplacian pyramid. So how we can create a Laplacian pyramid if there is no function available for creating them? So you can create a Laplacian pyramid, or a level of Laplacian pyramid is formed by the difference between that level in the Gaussian pyramid and the extended version of its upper level in the Gaussian pyramid. So this definition might be confusing to you guys, so let me explain you with the code what I mean by this definition. So what I'm going to do is, first of all, I'm going to take the top level layer of the Gaussian pyramid. So top level layer of the Gaussian pyramid is the last image which is generated using this for loop. So let's say we have 6 images or 5 images using this for loop. So what we are going to do is, because we have appended each and every image to this list, right? So we have all the images inside this list, so we can just get the last image using the indexing. So again, I'm going to use the layer variable, and then I'm going to just say gp for Gaussian pyramid list, and then there is the index 5, because last image will be available at the index 5 of this list. So we get the last image of that Gaussian pyramid, and then let's show this image. So I'm going to just say cv2 dot IamShow, and this is the upper level or the last image. So I'm going to say upper level Gaussian pyramid, and then we are going to pass this layer variable here. So this is going to show just the last image of this list, and let's just comment this code out because we don't want to see all the images. And then I'm going to create a new list for Laplacian pyramid. So I'm going to just say LP for Laplacian pyramid, and then I'm going to create a list using the layer variable itself, as we have done for the Gaussian pyramid list also. So the first element here is the layer variable itself, and now we are going to use the for loop, and then I in range. And this time what we are going to do is, you might already know how to use the range function, and if you don't know, you can see you can give the stop integer here, or you can give multiple parameters here. So you can see there is one more implementation of this range function. So you can give the start parameter and the stop range. So start is the starting point, stop is the stopping point, and also you can give the steps. So this step means in what number you want to reduce. Okay, so let's say we want to start from 5 and then we want to go until 0, and we want to reduce in the step of -1. Okay, so 5 4 3 2 1. So let's print the value of I first of all, if you might be interested in the result of this range function. Then let's just run this code and let's see what happens. So this is the images which we get, but we are not interested in these images, we are interested in the print function output. So you can see the output of this print function code is 5 4 3 2 1. As I said, the lower limit is not reached. So if you give 0 here, then it's going to go until 1 and not 0. If you give 6 here, then it's going to go until 5, not 6. So let me repeat the definition of Laplacian pyramid once again. So Laplacian pyramid is formed by the difference between that level in the Gaussian pyramid and the extended version of its upper level in the Gaussian pyramid. So let's first create the extended version of that level. So we are going to just create a variable called Gaussian extend or extended, and then we are going to extend the level of that image which are there in the Gaussian pyramid list by using cv2.pair_up method. And here what you need to give is the Gaussian pyramid list, and then we just need to get the index I from this. So this line gives us the extended version of the upper level in Gaussian pyramid. Now let's create the Laplacian pyramid. So Laplacian is equal to cv2 dot subtract, because we want to find out the difference between that level in the Gaussian pyramid and the extended version of its upper level. So I'm going to just say GP for Gaussian pyramid, and then we are going to just say I minus 1 as the first parameter, and the second parameter is the extended version of the Gaussian upper limit. And now we can use the IMShow method to show all these Laplacian images. So I'm going to just say cv2.IMShow, and once again I'm going to use str function to convert from a number to string, and then in the next parameter I'm going to just pass the Laplacian parameter here as an image source. So what do you think? Will this code work? So let's see what happens when we are going to run this code. So you can see the Laplacian pyramid looks just like the edge detection. So all the edges are shown here on every image. This is the first level, this is the second level, third level, fourth, fifth level. So these images are called the Laplacian pyramid. Now what is the use of creating those Laplacian pyramids or the Gaussian pyramids? So the Laplacian and Gaussian pyramid helps us to blend the images and the reconstruction of the images. So these are the two benefits of creating those Laplacian and the Gaussian pyramids. So in the next video, we are going to see how we can blend the images, or how can we reconstruct the images using the OpenCV and the image pyramids. So stay tuned, and I will see you in the next video.